Hey guys, welcome back to the third part of this practical course. As I've mentioned in the previous video, in the calibration tab, you can use different optimization and objective functions in order to find better combination for using for your case study. And in this part, I want to talk about the sensitivity analysis of AWBM model. However, in the previous section, I talked a little about this concept. This model has, I think, about 8 parameters, and some of are low sensitive and some of are high sensitive. And you can find the most sensitive of these parameters by using the sensitivity analysis. Okay, let me to select one of these parameters, for example, BFI, and the minimum and maximum value of these parameters varies between 0 and 1, and the calibrated value must be changed between these numbers. Okay, let me to select the objective function and click on plot response curve, and you can see by variation of these parameters the Nash statistical lift values change dramatically. For example, by increasing the BFI, the Nash statistical lift decreases, and it means that the performance of this model is very sensitive to BFI index, and so we try our best to estimate the BFI index accurately for our case study. However, this variation is not true for other parameters. For example, some parameters such as A1 is a little bit, the performance of model a little bit sensitive to this value. For example, by increasing the A1 value from 0 to 1, the Nash statistical value decreases from 0.48 to 0.45, and it means that the performance of this model is a little bit sensitive to A1, and also you can do this for A2, and also it means that the AWBM output is not sensitive to A2. And also you can do these processes for different parameters, and finally by comparing these curves for all parameters, you can find the most sensitive parameters, and this option is very practical for defining or finding the more sensitive of parameters. However, if you use the models such as Sacramento, Tank, or SMAR, and also you can do these processes for that models. And also there is not other thing to explain. And finally, in the simulation section, you can plot the calculated, for example, from the start, and this run is based on the calibrated parameters. And also you can plot full duration curve, calculated for runoff at a monthly time scale, and finally you can click on save runoff, and you can store your runoff at different units, for example cubic meter per second, and save runoff as, and store or save the runoff with the comma delimited tab format. And I think there is not any other information to talk about that, and just you should I think the most important section is the calibration tab, and you should try yourself best to find the best optimization method and objective function. And also in the objective function you can use the one objective or two objective for better calibration of your model. And I highly recommend you to try to use different optimization method for just one objective function, and then after defining the optimization, the best optimization method, try to improve your model simulation by selecting the secondary objective, for example, runoff difference, flow duration, and base flow too, because using the secondary objective will improve your model performance. And as I mentioned, my data set is in monthly time scale. However, for daily time scale, you can do these processes easily. And in this section, I have prepared a daily time scale. For example, let me to open precipitation, and you can see it. As I mentioned, this is months, this is day, and this is year, and this value precipitation. Okay, and I have a precipitation time series from 1948 to 2003. And let me input these data sets, and you just need to drag and drop your data sets, evapotranspiration, and flow values. Let me select millimeter per day, millimeter per date, and cubic meter per second. And as you can see, these values is related to daily time scale, and you can click on date tabs and click on updates in order to define the warm-up, calibration, and verification. Let me click here, and you can use this part for warm-up and this part for calibration and this part for verification. Keep in your mind, for every hydrological model simulation, you just use 80% for calibration. Sorry, you should use 70% for calibration and 30% for verification. And this is the standard criteria for all model simulation for different case studies. Okay, I think there is no other information to talk about that, and you just prepare the required input data sets and focus on a calibration section to find the best one for your case study. And for using this model, you need to create or log in this website, and after that it allows you to install and open it in your computer. And also I highly recommend you to go to the eWater toolkit and find more information about this model and other models which is developed by this company. For example, you can find different models, for example, AquaCycle, BC2C, and Shoot, and other practical software for using in your case study. However, there are other Rainfall-Runoff models such as HydroAi, which is very similar to AWBM model, but AWBM, or I mean RR model, have different aspects compared to HydrOi. And also you can find the RR model in this section and go to the download software, and you need to log into this website and press agree, and also you can download this model. As you know, the size of this model is very low and you don't have huge computational capability of your computer. And also you can find a different version of this model, and also you can go to the documentation and download the user guide file of this model. Okay, I hope this course will be useful for you for your case study, especially for rainfall runoff simulation. And if you have other question or a problem, please let me know, and I try my best to answer all of your question. If you have, as I've mentioned, if you have need other information, I recommend you to go to the eWater Toolkit website, and you can find more about news, events, and publication related to this practical model. Okay, have a good time. Bye-bye.